campaigns with Checkpoint, that is one of the gold sponsors for RootedCON this year. We started the relationship with Checkpoint past year, and it is excellent. The last speech was very, very interesting about collusion and how to exploit mobile applications in Android and in other devices. And Alon, I think we'll talk about HUMMINGBAD. Right. That was an interesting campaign, okay? So it's up to you. I will review.
Okay, so while we are solving the technical problems, hi everyone. My name is Alon Menczer. I'm from Checkpoint. I'm a mobile security researcher, and I'm here to talk with you about a mobile malware campaign, as he said, which we call HUMMINGBAD. And well, wait a minute. So we'll solve this.
It's a security alert. Let me cancel this one.
Okay.
So here is Afghan. Let me check if this works.
Great. Here. Thank you.
Sorry.
It's okay. Okay, so let's start. As I said, I'm going to talk about a mobile malware campaign called HUMMINGBAD. But before I can actually tell you how it works, we need to talk a bit about the world in which it operates. And the world I'm talking about is the advertising world. And more specifically, I'm talking about the mobile ad business. First thing you should know, this business is huge, okay? According to some estimates, just in 2016, over $100 billion were spent on advertising in mobile devices, okay? Second thing is that in 2014, about 50% of all digital advertisement were inside of mobile apps. Just 2 years later, in 2016, we're talking about 67%. So you can understand that it's not just huge, that the world is going in that direction, going in the mobile direction with advertising. And the last thing you should know now is that this world is under attack. According to Forensic, which is a company who prevents and researches ad fraud, up to 33% of all mobile ad traffic can be considered fraudulent. So that's a lot, and I leave it to you to calculate how much money is that worth. And they are not alone with this number, because other companies in the field are talking about similar numbers. Okay, so how do ads actually work? We have many players in the game, but the main two players are those two. At the right side, you have a publisher. That's a website developer or a mobile app developer, and they have real estate. They have blank space in their sites and applications, and they want to make money out of it. They are also called the supply side because they supply traffic. On the right, in the left side, we have an advertiser. It could be a brand like Coca-Cola or an agency that represents them, and they want to sell their product. And in order to sell their product, they want to advertise it. So they would pay for that, and a good place to advertise is at websites and mobile applications. So you would think that in the age of the internet, in the modern world, it would be really easy to contact the advertisers. The advertiser could connect the publishers and just make business. But in the advertising world, it just doesn't work like that. Because there is so much money in this game, the advertising game, as you already know, everyone wants to be part of it. Everyone wants to be part of the game. And another reason for those two players, they can't connect each other directly, is because the need for optimization in this business is really, really huge. Because there is so much money involved, optimization is really, really important. So how does it actually happen? The advertisers don't contact directly the publishers, because there are millions of applications and billions of websites. So contacting each one directly won't be good. So they use something called a DSP. This is demand-side platform. As I said, the advertisers are called the demand side because they demand the traffic. And the DSP is just a platform for them to buy traffic from, okay? The publishers, they don't want to work with the DSPs directly, and there are two main reasons for that. The first reason is if the DSP won't be able to buy even the smallest amount of traffic each day, this is money they are losing, and they are in the game for money, so this isn't something they allow. And another thing is a publisher might have special traffic or specific traffic. What do I mean by that? Let's say that there is a website about cars, okay? You can understand that almost all of the users that will enter this site will be car lovers, and the chance that they will buy something connected to cars is really, really higher. So a company that sells cars would like to advertise to those people. So if a DSP doesn't have a company or a brand that sells cars under it, that it works with, it won't buy this special or specific car-loving traffic in the same price. So they want to work with several DSPs. So they work with something called an SSP, which is a supply-side platform. Basically, a place to sell your traffic to. And as you can see, this is getting more and more complicated, and I don't want to talk the whole hour just about this. So let's just say that there are more players like ad exchanges and ad networks, and they all make money from one thing: buy traffic cheap, sell it higher, okay? And this isn't too good, because this is a fertile ground for fraud. What do I mean? Because you need to, they want to buy something for cheap and sell it higher, they can, and actually they do buy fraudulent traffic. They buy traffic which isn't real, and they sell it at a higher price, and they do that as long as they can maintain a delicate balance between the revenue that they will be making from this and their good name and their ability to make more business with more companies, because if all the traffic they will be saying will be fraudulent, they will have bad name, no one will work with them. So if it's something, if they can maintain this balance, it's good for them. It's important to say that all the companies I'm showing here are not connected to fraud in any way that I know of, and they're just given here as examples because they're big and known companies in their fields. So what exactly is this traffic I'm talking about? What are the events that publishers get paid for? Well, the simplest event and the cheapest one is called an impression. An impression is when you get a user to see your advertising. It could be a banner, it could be a video, and it's pretty cheap. Slightly more expensive traffic are clicks. When the user clicks, this is another event. And the last event that I'm going to talk about, and the most expensive one, is called a conversion. A conversion means you got the user to do what you wanted them to do. In the website world, in the PC website world, it's mostly registering and filling out forms. Let's say that there is a dating site. They don't want to show just a video. They want to register. So if a user clicks the advertisement and registers, this is a conversion. In the mobile world, we are mostly talking about installing and activating promoted applications. Okay, so who is actually creating this fraudulent traffic? I said 33%, so where does it come from? Well, one of the sources are malware developers. They are technological, they know the advertising business well enough to exploit it, and they have keen sense for money. Because easy money can be made here if you want to commit crime. So they are creating a threat, which we call in Checkpoint RAF adware. And this is, to me, an interesting type of threat, which you don't hear enough about. And it's not like it's only a mobile threat, because if any of you ever left a checkbox unchecked in an installation process on your PC, and minutes later you found a new toolbar, which I suppose most of you did, or your mothers and fathers, then this is actually the same thing. Just in the last year, we have seen 3 international scale mobile malware campaigns. We have seen Ghost Push, which later evolved to Gooligan, and we've also seen HUMMINGBAD, which I'm going to talk about and focus today. And the motivation for creating all those is money, and they are making this money by ad fraud. So let's look at some news regarding HUMMINGBAD and the damage it has done. Okay, so now when you believe me that this was something big and something that really happened, let's talk about how it worked and what is it actually. Well, we first met HUMMINGBAD in February 2016. It was installed on a device of one of our customers, a major financial company. And at that time, we did not know the extent of the attack. We didn't know that there's something so big behind it. But we can already see that it used several different techniques in order to make fraudulent money from advertising. One of them was to install applications. And it also contained exploits to root the device, and we'll talk about that later. So this is one device, one sample, one infection. How did we get from this to millions of infected devices? How did we figure that out? Well, this story starts with analytics engine, something like Google Analytics, which I suppose you have all heard about. Every app developer, application developer, and it seems that also a malware developer needs these kinds of analytics engine in order to track his campaigns. HUMMING is a completely legitimate ad analytics business based in China, and they let developers create special events, custom events that they want to track on devices. For the HUMMINGBAD, it was really useful because they wanted to track how many devices they rooted today, to know how many devices they totally compromised until now. This was very important to them. And in the first sample we have found also references to HUMMING, this Chinese analytics business. And by a few Google searches, we got access to their SVN repository, to the malware developer SVN repository. And inside that repository, we have found credentials for HUMMING. So I'll let you look what we can find inside. Well, this is the number of users that they have seen each day. And I think it's more right to say these are not users, these are victims. And as you can see, the numbers are huge. Hundreds of thousands of users, unique users a day. If we look at the total amount of users they have seen at all time, we're talking about tens of millions. But this is not everything there. We can also see the list of all the applications that were registered on this dashboard. There were more than 200 different applications. Almost all of them were infected with the HUMMINGBAD malware. And if you can see, the names of the applications are a bit weird. This is not something I would download. Something like SSP Hammer Offers. I wouldn't download it. So why is that the name? Well, SSP, as I've told you before, is the supply-side platform. This is actually the company they are committing fraud through. You can see Hammer Offers, Cheetah, and more SSPs here that actually they are committing fraud through. And those were the names of the application. And I think this is a good name for those applications because committing fraud was actually the only thing they did. So from this, you can understand this is not something developed by a 20-year-old hacker in his mom's basement, right? This is something big. So who did it? From the SVN repository and the HUMMING account, we could track back traces to a company called YingMob, which is a Chinese mobile ad tech business. If this name rings a bell, maybe it's because you've heard of them as the developers who signed Spectre, which was one of the first iOS malwares to infect non-jailbroken devices. And actually, Spectre, the iOS malware, also used several techniques to make money from ad fraud. So, yeah. It's important to say that this company this is not a malware company. They have legitimate business, ad business, and they also found a nice way to make some money, so they created a side branch which is creating those kinds of threats. So how much money did they actually make? We are talking about millions of impressions a day and millions of clicks a day, and also tens of thousands of installations per day. Those are installations that were initiated by them and not by the users. This is without user consent. And the money that they were making each month, I don't think that there are many little startup companies that would be ashamed of $300,000 each month. So as you can see, this is nice business if you want to commit crime. What you can see here is the distribution of infections around the globe. So most of the success was in Asia, and as you know, they don't have Google Play in China, so malwares are attacking there a lot. And also, this is the closer to the home of the developers, so they were stronger there. And you can see that they also had a beneficial amount of infections in the Americas, and especially in the US. So why does an enterprise, or actually you, care about this? They commit fraud on advertisers. So Coca-Cola lost money. I don't care if they lose money there. I don't have money there. So why do we care? Well, first thing is HummingBAD roots your Android device. Android devices are not supposed to be rooted. They come out of the box, they are not rooted. And they are not supposed to be rooted, because when they are rooted, they are more vulnerable. So because this roots your device, you should worry, and an enterprise too. And the second thing you should remember here is that there is one reason that this campaign is here: make money. And there are many different ways to make money with mobile malwares. You all know about what ransomwares are, you all know what botnets are, and with so many devices you can make so much money. And I think those are just the ways that we know, and the world is evolving. And if you've heard Kaspersky, as he should research and blog about a malware called Switcher some months ago. This malware had the ability to try and access the admin panel of Wi-Fi routers, and to change the DNS default address. And by doing that, just thinking of 10 million devices, mobile devices, Android devices, roaming around the world, everywhere, changing the DNS address of every router they are logged into, or 10% of those routers, so much traffic would be redirected to those criminals that it's crazy. This could be serious damage to enterprises and also to regular people, like your own device, your own home network. So there is a problem here. Now that you know what HummingBAD is, let's dive in and talk about how it actually worked. Well, every campaign must go through several stages before it can actually make profit. The first step is to infect devices. The second is to do privilege escalation, or get the permissions you need in order to do to commit your crime. And the last one is the malicious activity itself, committing the crime. So the infection process of HummingBAD, we can see that the application was served from several adult content sites. We have seen many of those infections. And this is something pretty popular in malware distribution. And I think this is because the user is vulnerable at that time, and this gives a chance to infect him. The privilege escalation, well, HummingBAD contained a rootkit. It contained a large pack of open sourced exploits. This means that those are exploits that were already known and were actually closed in later versions of Android. But most Android devices were still vulnerable at that time. And we saw hundreds of routings each day. But rooting a device can raise suspicion, and it could also cause some problems. So why did HummingBAD, who just wanted to show you some ads and install applications, need to root your device, create so much noise? Well, the first reason here is persistency. After infecting a device, they don't want to be uninstalled, because every minute, every second they're on so many devices, they're making more and more money. So uninstalling for them is not an option. So, well, persistency with simple users can be pretty simple. And what they did here in HummingBAD, and it's pretty popular, is that they tried to trick the simple users. How they do that? How can they do that? Well, they used package names, Android package names, that sound like Android system applications. For example, com.android.sounds. Let's say I'm a simple user. I think I have a malware because weird things are happening on my device, and I'm trying to look for suspicious applications. Even if I suspect an application called com.android.sounds, I don't think I will uninstall it. I can ruin all the sounds on my phone. I won't have sounds, so I don't do that, right? But this isn't enough, because the more technological users would see that this is not something real. This is not something that was on my device before. So they would uninstall it, and this is not good. So by gaining root permissions, they can install the application on the system partition. What does that do? Well, Android file system is divided to partitions, and most applications are installed in the data partition. And those are applications that you can uninstall via the UI. All the applications that are installed in the system partition cannot be uninstalled via the UI. The button is great, you can't. And if you want to delete it, well, you would do something like a factory reset, right? But the factory reset doesn't help too, because the factory reset deletes only the data partition and not the system partition. So in order to delete it, you need to flush a new ROM or actually use the root permissions to delete it. So this is very good for them. And another good reason for rooting a device is getting more capabilities. Okay, they want to install applications. Installing an application, when one application wants to install another, it needs to show a prompt to the user. And they don't want to do that. So by using root permissions, they can do it silently. And they can also do code injection. And by using code injection on the Google Play application, they did some very interesting stuff. If we look at the distribution of Android devices by version, you can see that almost all of them are Android 4.4 or lower. And this is because those are the versions on which the exploits in the exploit pack worked. And it's not like this is very different from the normal distribution of all the users, because even today, 1 year after we first saw this malware, about 1/3, 33% of all the Android devices are below Android 4.4. So those exploits still work on a lot of devices. How did it actually commit the crime? For that, we need to understand a bit more about how advertising and actually tracking installation works in the mobile world. Let's say that this is the regular flow. This is how it should work. A user clicks an advertisement and is being redirected to the ad network and also to the attribution provider. The attribution provider will save a unique ID of the click event and will use that to confirm that there was an actual installation of a promoted app afterwards. So after that, you are redirected to the Google Play application, but this redirection also contains what is called the referrer ID. This referrer ID is most of the time the unique click ID. Okay? So Google Play remembers that because of click number this and that, this user was shown an application in the Google Play application. If the user decides to go on, install, and activate this application, the application contains an SDK which receives this intent, the install referrer intent. Intent is the normal and the basic inter-process communication in Android. So it catches this intent and tells the attribution provider, I was installed because of this click ID. And then the advertiser has to pay the publisher money because the publisher has shown a click, and because of this click, an app was installed. Okay? So this is how it should work. HUMMINGBAD contains a module called SSP, also after the supply-side platform, because this is the module that actually does the fraud here. This module shows the user advertising all over your screen. And it's not in the context of the application. You're just using your mobile device, surfing in the browser, and voila, you have an advertising all over your screen. This is annoying. You want to close it, so you try to push the close button. But HUMMINGBAD won't let you do that. It puts another button over the close button. So actually, when you click that button, an application, the promoted application in the advertisement is downloaded from the CNC server of the malware. And after that, it installs and activates it. How does it do that? How does it do that? Well, as you can see here, it uses the super user privileges and calls the package manager, the Android package manager, to install the application it just downloaded, and also to activate it. Why is this important to actually activate the device? Well, as you remember, the application needs to tell the attribution provider that it was installed, so it must be activated to do that. How does the fraud flow works? Well, we don't need Google Play. We can download the application from the CNC. And after that, we install it and activate it. But there is a problem here, right? It needs to get the install referrer intent in order to know who installed it. Well, no problem. HUMMINGBAD will send that for you. OK, so this is nice. But they also used another technique which is better. And this consists of injecting code to the Google Play application. So this, of course, requires root, because they're using the ptrace syscall, which is a syscall in the Unix and Linux operating system. And this syscall was created in order to let one application debug or look at what other applications are doing. So they're using ptrace in order to inject code into the Google Play application. This is not something that they developed themselves. They are using a library developed by Chinese people, and it's very well documented if you know Chinese. I don't. So I explained what happens here. You have an injecting application and a target application. And the injecting application can insert any native Android native code into the injected application, into the target application. And this is how the native code that HUMMINGBAD injects into the Google Play application looks like. So you can see that it loads a DEX file. DEX file is Dalvik executable. This is the Android executable. And it loads this into the memory of the Google Play application. And after that, it also calls a very nice function called gpclick gpapk. What does this function do? Well, let's look at the Java code. Well, you can see it maps all the Google Play UI. All the buttons from the Google Play are mapped here. And if the download you're seeing is the download button, the button we're saying is the download button, click it. So by showing an advertisement to the user, and after that injecting code into Google Play application, and they can just simulate any events in the Google Play application. So they are searching for this application, downloading it, installing it, activating it in similar methods as before. And now it's even easier because Google Play will send the install referrer intent for them, right? This is beautiful to me because they haven't downloaded anything from the internet. Google Play does all the work for them. The user just see applications that are installed. So HUMMINGBAD made millions, and we have researched it and told the world about it last year. But was this the end? Well, a few months ago, I've encountered the left app, the new app you can see. And it really reminded me of something. It was on Google Play. It had some malicious behaviors in it, but it really reminded me of something. And the application it reminded me of was a HUMMINGBAD application. Well, let's look why did it remind me this. Well, they are both called Whale. Whale camera doesn't make sense to me, so this was already weird. And so they are both have Whale in their name. If you look at the package name, again, Whale. And the new app certificate issuer was probably one of the droids from Star Wars, while the HUMMINGBAD certificate issuer was Sky. And this is also appears in the new application package name. And this, I don't think this is a coincidence. And we decided to call this new campaign HUMMINGWhale, of course. Easy decision. And if this is a whale and this is on Google Play, then we have to go on a whale hunt because this is not just one application in Google Play. The HUMMINGBAD guys are professionals, and this is something bigger. So we went on a hunt, as I said. OK, so we have one application, and we think there are many more. How can we find them? Well, first thing you can do is to look at the Google Play developers account, right? This was in Google Play, and I can see all the other applications that these developers uploaded. There were none. This was the single application in this Google Play developers page. And this is actually a very good practice for malware developers, because if one application is exposed, they don't want all the others to be exposed too. So what we did is to use an algorithm, a similarity algorithm, in order to find more threats that are similar to this in our malware database. And though we found more cameras, also in Google Play, and also in them, there were no other applications developed by the same developer, so this is now a pattern. And we felt like there were more, so what can we do? Well, now when we have more than one application, we can understand what makes this family special. What are the patterns inside? So we decided to create Yara rules. Yara is a pretty simple language to write mostly static signatures, and it can be really easily ran on a large number of binaries. So by writing those Yara rules, developing them, and running them over our malware database, we could find more cameras, more on Google Play. And some of those were installed in the millions. So we thought that still this is not enough. They have more. We knew that they have more. We decided to use the big guns. And in order to explain what were the big guns, I need to talk a bit about how we actually analyze and understand what applications do in our product, in Checkpoint. So we use behavioral analysis. This means that we have several different engines that analyze the application in different ways. So just as an example, let's look at two of them: static analysis, and static code flow analysis, and dynamic analysis. And we can understand many different things, many behaviors, many facts about the application when it is analyzed by one of those engines. So let's look just at the advertising domain as an example. With static analysis, we can understand which ad SDKs are implemented inside this application. And we can also see code flows which are relevant to ad activity. With dynamic analysis, we can actually catch pictures of the screen overlays, the advertisement that are shown, and also the actual network calls that were made during the run. So this is just an example of the behaviors we can understand. There are many, many more. And this is important because what we did, I'm showing you a simple version of what we did now. Okay, so we took all the camera applications we have in our system. And about each one of those applications, we know which behaviors we can see in them because we analyze them. And this is all the applications unordered. I just, the more anomalous or weird or rare the behavior was in all of our camera applications, it's red, okay? So you see all applications have used the camera API and the flashlight, but almost none of them contain anti-emulation techniques, right? By using an anomaly detection algorithm, we were able to order all these applications according to how suspicious they are, how anomalous they are. And the top applications were the HUMMINGBAD applications. So this was the simplified version. Let's look at the real one. So like before, each row is an application, each column is a behavior. And you can see here that the top row contains many, many behaviors that are really rare. And actually, almost all of those behaviors hadn't actually been detected in any other camera app all over our system. So this was very weird. So you can see there is a big bunch of applications at the top. Those are the HUMMINGBADs. By using this anomaly detection and running it, we could find more applications. And actually, some of those applications weren't cameras. So we were really happy to see they can create other kinds of apps. There were also cleaners and VPNs. So how did it actually look in Google Play? Well, really nice cameras. And you can see that some of them were downloaded a lot. And there were really positive reviews. So my favorite one was, almost ruined my phone. Google, get rid of this app before it turns people's phones to garbage. Couldn't agree more. And I suggest you, next time before you download an application, read some reviews. How did it look like when you actually install the application? So we have orange camera, which sounds like a really good camera. We can open it, and we can see wonderful collages and effects that you can use on your pictures that you take here. And this is really nice. And you can also see advertisement all over your screen. And you can also see the application disappearing. So this is really nice. And now you're being redirected to Google Play. So we'll talk about what actually happened here in a minute. But before, I want to prove to you that Hummingbad and Humming Whale are actually connected, because the names are a nice lead, but that's not enough to actually say this is the same developer. So as I've said, they both used the same, the target was the same, to make money using advertising. And the technique was also the same, installation of apps. So another connection is the certificates. Well, every Android application has to be signed with a certificate, an X509 certificate, like we use in TLS and SSL, very popular. And those certificates don't contain only cryptographic information, they also contain information about who issued this certificate and who signed this application. So, as I said, Humming Whale developers were smart. They divided their applications to different accounts in Google Play, and they also did this on different applications. Each application was signed with a different certificate, and this is also good. They just forgot one thing, to change the issuer. Many of them contain the issuer A and B. I don't know what that means, but it probably means something for them. And they made another mistake, and this certificate with the A and B issuer was also used in Hummingbad. So this is something they forgot. Okay. The code structure and style was similar between those two malwares, and they also contain a really nice native file, native process. They called it daemon. This was the actual name of the file, not the file type. And this daemon, what it did is to run a native process in the background of the device. And this process would create a local socket with the main application. And if this socket was interrupted or closed, it would understand that probably the main application was closed. So it would just restart it, so it would always work. And it also created some kind of watchdog. It used the Linux iNotify in order to check if the main application's files are always on the device. If they are deleted, it connected the CNC server and told it that on this device, this and that malware was removed. They also forgot to change the log tag they used. They used WZH all over the place. So that's nice. And when we're talking in encryption, they made some progress. They used better things in Humming Whale, but they used hard-coded keys in both of the campaigns, and those keys were hard-coded into the encrypted file itself in the file header, in a similar technique in both. In Hummingbad, we've seen XOR encryption. What I mean here is that the whole module, the whole payload, was XORed against 1 byte. And they were not even they didn't even thought about which byte to XOR with. They just did 010101, which is 85 in decimal. This is not really encryption, and this is really easy to decrypt. So in Humming Whale, they used RC4 encryption, and the seed for the RC4 was also encrypted, which was really good. And this seed was encrypted with DES. But the key to the DES encryption was in the file itself. So I don't know. Okay, so this is a paradigm shift from Hummingbad. They invaded Google Play, and they could do that mainly because two things that they've changed. They incorporated anti-emulator techniques and pretty advanced stuff, and they also dropped the rootkit aside. They don't use exploits anymore, and of course that with exploits you cannot enter Google Play. So let's talk about anti-emulation. Why is it even important? Well, most researchers and also research tools use emulation in order to run files or binaries on devices. Because if this is really a malware, I don't want to install it on my device. And if I want to check 10,000 applications a day, this could be automated easily, and each device could be erased in a second. So by using anti-emulation, by detecting that you are running on an emulator and deciding not to run the malicious behavior, you can escape from being detected. And this is important, as we said, for the HUMMINGBAD campaign. So there are two main Android emulators. The first is QEMU, which is actually used in the Google emulator itself too. And the other one is Genymotion. In order to evade QEMU, it checked for pipe files. And this is pretty smart because most anti-emulating Android malware look at the IMSI or at the phone number, and if it's something like 000, then they understand that this is an emulator or on device properties, which are relatively easy to change. If you are a security researcher and you don't want to be detected, you can change them pretty easily. But searching for pipes is better because it is really hard to change the infrastructure itself of the emulator. So they evaded QEMU. And with Genymotion, they looked for several types of files and also for the Genymotion daemons. And this was pretty good too. And this was also taken from an open source project. And you can check it out later. And now Humming really is free to do what they want because they are not running on an emulator, and this is real device. So what do they do when they know that? We have the main application. And inside it, we have two main components. We have an encrypted file called group.png, and we have the Droid plugin. A Droid plugin is a library, which is actually some kind of virtualization library because it enables any application to run any APK, any Android application, inside its scope. So it doesn't actually install the new application, it runs it, and it can do anything the virtually running app. And it thinks that it is on a really installed on a device. So this is really nice. What is inside this beautiful picture, this group PNG? Well, this is not actually a picture. This is an encrypted APK, an Android application, which is then decrypted when the malware is installed, and it is run inside the virtualization solution, inside the Droid plugin. And something nice here is that the main application has to have all the permissions that the installed application need. So many applications using Droid plugin have a lot of permissions. So they're running this, and this group PNG APK contains something very similar to the SSP module that we have talked about before, which commits the fraud. So it shows advertising all over your screen, and this goes to the attribution provider, and then it downloads applications from the CNC, and after that, when an application is downloaded to your device and promoted application, it can be also installed using Droid plugin. So the promoted application is actually never installed on the device. The user doesn't see it at all. So the fraud flow here looks something like that. The application is downloaded from the CNC, and then it is run on a virtual machine and also activated there. And also here, HUMMINGBAD needs to send the install referrer intent, so the promoted application, which doesn't know it's not really installed, will tell the attribution provider that it has been installed, and the malware developers make money. This is very smart because this is silent. The user doesn't see almost anything beside the app, and this is not using any exploits, so they were very quiet, and the actual malicious payload was encrypted, so they got into Google Play. Sum it all up, I want you to remember three things. The mobile attack is huge, and it's under attack. Second thing, malware can and do infiltrate Google Play, so there's nowhere safe, and you need to protect yourself. And the last thing is, which was a bit of a surprise to me, that there are no only professional malware developers only in the side of cyber weapons. They're not creating just spyware. They're also creating anything else which can make a lot of money for them. Thanks a lot for listening. I hope you enjoyed. And if you have questions, now is a good time. And you can also check out our blog. to read more stories. Thank you.
Thank you so much. Questions? Preguntas? No os veo. Preguntas? ¿Alguna por aquí? One quick question.
Yeah, sure.
What will happen in the future? Do you feel there will be some kind of better controls on Google Play Market to avoid this kind of infiltrations? And do you see any way to protect the user from this click jacking and the injection in a simple way to work in every device?
Okay, so about the first thing you asked, of course, that when we discover things like that, we work with Google to detect and remove those kinds of applications. And I think that the Google Play uses a software called Bouncer, something they developed in order to stop apps from being uploaded to Google Play. And I think that they are getting better, but the market is also growing. So the malware developers are also evolving. And I hope that in the end that they would be able to stop everything. And about the second question you asked, there is some kind of, always some kind of war that goes on in these kinds of things, because one of the problems that were with Android that there are many banker Trojans, and banker Trojans want to show you a screen overlay over your own bank, so you would fill your details and it would be sent to them and not to the actual bank. So in order to do that, they need to know which application is in front of the user. And at first, in the first Android versions, it was really simple. You had an API to do that. And after many malwares used that, Google, this API was deprecated. But malware developers found other ways to do that. And with each new Android version, and also with the last one, you can see them blocking APIs that malware developers are using. But this is actually, one, it stops legitimate developers from doing things that they want because those APIs are deprecated. And the second thing is that malware developers, when they want, they find the way. So I'm not sure there will be ever a real way to stop social engineering. And you can't block everything because you wouldn't be able to create regular and legitimate apps. And I think one of the nice things about Android is that you have access to all those things, that you can see what's running and interact with that. And iOS is more closed, so there are many advantages and disadvantages to blocking these kinds of things.
¿Alguna pregunta más? I have another one.
Okay.
It is not, in my opinion, is it risky to have a native binary because the implementation should be absolutely simple to avoid having problems in different hardwares and devices? Why they do choose to go to a native binary?
So first thing, I think that native files are, it's easier to avoid detection by using native code. And the second thing is that using native code sometimes gives you more options about what to do. So it's obfuscation and hiding from antiviruses at one side, and another thing is getting more power. You can do everything when you're running native code, and also on rooted devices, you can actually do anything with this with native code, and Java is still using the Android APIs.
A final question? Okay, thank you so much, Alon.
Thank you for listening.